you ever turned on your TV or radio, stopped, and given a thought as to what it takes for you to be able to watch or listen to your favorite shows 24/7, 365 days a year, and then put a face on the people who are working behind the scenes for you? In BAI's Engineering Knowledge series, we'll be speaking to the specialists that make everything in broadcast transmission happen, going behind the scenes and gaining insight from them on the role they play to keep broadcast services on air. So what is BAI's Engineering Knowledge series? It's an initiative that outlines BAI's culture of proactive and continual improvement of its network assets, essentially looking at the heart that drives the machine. In this series, you'll hear from our various engineering specialists talk about the engineering design principles they apply when replacing or upgrading network assets and how they keep the broadcast machine ticking for the long term under some adverse conditions. Welcome to Session 1. My name is Masoud Rasouli and I'm the Head of National Broadcasters at BAI Australia. Today's session is on Power and Buildings and will be presented by Patrick Maraun, Manager of Power and Buildings at BAI Australia. Pat is the Engineering Design Authority on all things related to power and buildings in the broadcast network. Pat, welcome.
Thanks, Maz, and thanks to everyone tuning in. So I guess a little bit about me, if this is our first time meeting.
Yes.
So as Maz mentioned, my name is Patrick Maraun. I've been doing mission critical infrastructure support for around about 20 years now. So it's I guess the field that I know and love. I began my career in UPSs, supporting large data centers and high availability facilities. From there, I transitioned to a global telco who was deploying data centers nationally throughout Australia, just prior to .com bust, I guess we call it now, and during the boom times. And then subsequent to the bust, I transitioned to a more of an operational role with them, which was more consolidating their network and really getting into the facilities management side. So I'm an electrical engineer. I guess if you go back far enough to uni times, then I also did some postgraduate qualifications in facilities management to support that operations side of my work, and came into BAI around 15 years ago now as a design engineer, and then transitioning through team leaders and manager roles.
Fantastic. So you've got enough qualifications for us to call you a specialist.
Yeah, that's right. Actually, recently also added an Uptime Institute accredited tier designer certification, which is
what is
for those
that?
who aren't aware. The Uptime Institute are a peak body for mission critical availability. They're an interesting bunch. They started life as a whole bunch of sort of Wall Street financial house data center owners who were sharing horror stories about when things went wrong and what they could learn from each other. And so if you can imagine from those humble beginnings, they've now rolled up sort of hosting providers, carriers, obviously still financial services companies, anybody who has mission critical data, and they run quite a mature and highly developed training and accreditation program, both in terms of facilities and then also in terms of in terms of design engineers and operations specialists.
Right.
So yeah, it's I guess my bread and butter. It's certainly my passion is keeping the lights on and keeping the temperature right and keeping the equipment that generates the service in the environment that it needs.
Fantastic. So you've told us a bit about yourself. How about telling everyone about your team and the roles that they play in keeping broadcast services to air?
So the Power and Buildings team consists of myself and seven engineers, a mix of engineers and team leaders. A couple of vacancies in there. So if this sounds like the field for you, then feel free to reach out if you're listening. And a really good mix of people. We're a fairly low churn group, many team members having multiple years of service now with the organization, 5-10 years plus, like myself. And I think the value that we add is that we come from a range of backgrounds. So there are people like myself who transition from one network owner into BAI as a network owner, and that gives a real sense of design being the start of the journey, not the end of the journey. Which, if you're a career designer, that tends to be the way you look at things. And then we also have people from the construction side of industry. So the people who have needed to take designs and then bring them to life, which comes with its own challenges, and I think brings its own perspective into the way that you design things and the way that you support them. And we've also had people come in from the vendor side. So some of the key suppliers that we use in our project work, that we've also been able to acquire people from those, and that brings fantastic knowledge. We have our own, almost our own help desk in the team for product information and trying to understand things, which again, quite critical in understanding what you're selecting for your designs, but then also very important as you support those assets through life.
Okay, so you've shared a little bit about your team. So why don't you talk to us a little bit about some of the engineering practices and principles that you apply to your work?
Yeah, sure. So we're a wide-ranging team. So really our journey with our assets starts at a strategic planning level. So trying to look into the future and making sure that whatever we're doing aligns with where the business wants to be 5, 10, 15 plus years from now, and that we have a plan in place for those what we call power and building assets, that covers that time frame, and also brings that asset performance and cost deployment, and also operational deployment into alignment. So from those beginnings, we then manage the detailed design process as assets are refreshed or installed through the network to support growth. We support projects through procurement phases, through construction phases, through commissioning. We are the ones who are the stewards for our records management. Good networks sort of live and die on the basis of their records quality, a very important focus for us. And then through operations and maintenance and decommissioning, we run an inspections program that covers off our the assets that we look after, and we work with our field teams to make sure that those assets, they can be the best designed assets in the world, but you only get the performance out of them that they were designed for if what happens at the end of the design is the way it should be. And so we get involved in that field, and then we provide reactive support. So when things go wrong within the network, then we're effectively on standby to help field teams, to help our contractor bases get a quick win out of whatever's happening on site, and then guide them through the restoration and remediation process.
That was not something that I was initially aware of until we started speaking about it. So you and your team provide level 2, level 3 engineering support when there's a fault or an issue with a power system?
Yeah, that's right. So we're an escalation for our field force deals with the problem as it happens via a 24/7 monitoring center and on call local staff. They have their own contractor base, but today's it's hard to be an expert on everything when you're in an operations space and you're in a fast moving world. So we're available to those guys for support, for technical support, for escalation, to resolve as they need, and that covers power systems, but then it also covers things like HVAC and fire systems, and even within power systems we talk about things like lightning protection and bulk fuel storage and fuel transfer, and obviously standby generation, renewable systems, battery energy storage systems. So really quite a wide remit and a lot of technical breadth to go into a lot of depth across. It's a wide and deep pool.
Oh, absolutely. So I guess there's like some interest for you and your team to design a system that has a few fail safes and backups, just so that you're not getting up in the middle of the night and providing that support, right? If you don't have to.
No, absolutely, that's right. There's I think what separates us as a team, as sort of mentioned, we are a team of designers. We all design, but it's by no means all that we do, and I think that's really what separates us from I think others who design. They may design for a living. They're engineers and they're good at what they do, but for us, design is more about the beginning of a journey rather than the job starts and finishes when the design starts and finishes. And I think that's there's a perspective there that comes. I think you only get through hard-earned experience. You only get from seeing assets in service 5-10 years. Sometimes it takes a lot of years for a design vulnerability to show itself, and we have the benefit of that accumulated experience and build all that back into what we do to make not only our own lives easier, but for this really goes to our customers and our own wider team within the organization in terms of improving availability.
So it sounds like what you've described is the difference between a good engineer and a great engineer is someone who's been involved with something from, let's call it, cradle to grave, and has many, many years of experience with various different projects, different scenarios, and knows how to speak with various people.
Yeah, absolutely. Relationships are everything. We have a wide stakeholder engagement process that throughout the life of a project or an asset, and it can be obviously internal stakeholders, our customers on that side of the business. But then after requirements definition, we deal with regulators. We obviously deal with suppliers. We deal with contractors. We deal with our own other internal teams, property, health and safety, network management, or network strategy. There's really nobody, I think, in the business that we don't touch with at some point through a design process or a project. And I think that makes us better engineers for it. I think understanding what drives other people and what their needs are is important as a designer, I think.
You touched on regulatory. So, some of the principles that you apply to your engineering design, does that include things like regulatory compliance? And it can be a bit of a dry topic at times, but obviously a very important aspect of your design. Could you tell us a little bit about some of the regulatory compliances that you consider?
Yeah, sure, absolutely. That's we operate under, I don't call them 10 commandments, but we operate under 10 design principles that
should they be commandments?
Maybe they're in a perfect world, but yeah, they're I guess they're just concepts that we hold in mind whenever we're doing anything, and designs are sometimes very cookie cutter. We often do the same thing at multiple locations. It's the nature of being a network operator. But then designs are often
to that, though, right?
Absolutely, yeah. That brings great efficiency, and it's part of one of our key principles, which is standardization. That's definitely a component of that. Designs are standardized or repeatable just because of the nature of the equipment or the site or something very specific to that location. And so in not having that strict rule book, that design rule book that you might have adopted from something, we've been doing it a certain way for forever, and so that's just how we do it. But it's a highly refined process. Sometimes those wider principles that we operate under, they really inform both how we standardize, but then also how we treat things that aren't standardized. And I think, and you're right to bring regulatory compliance in as a starting point, because really that's a flaw. Like there's a minimum that we need to comply with, and this field here, it sounds obvious, and I think everybody who signs off on anything says that they'll do it in accordance with the minimum legal requirement. But the reality is that in our field, when we're obviously we're looking at electrical safety, we're looking at environmental management with bulk fuel storage, we do fire systems, so that's fire detection, fire alarm systems, it's fire and smoke control. And then on the building and architectural side, we have hazardous materials. Still, we have an operator network of, think back to when AM radio was first established in this country, all those decades ago. There's an amount of asbestos that remains in the network, so compliance regimes around that. And even with the newer technologies, if you fast forward to lithium energy storage and renewable generation systems, there's a whole bunch of compliance around that as well. So being able to say that you are compliant is one thing, but then being compliant is a lot harder. And to be frank, and there's a lot to know when we work with our supply partners to try and to give them the best head start they can to make sure that what they're building is not at risk of non-compliance.
Yeah. Okay. So regulatory is the first of the 10 commandments / principles.
Yeah. We've touched on standardization, but it sounds obvious. I think any network owner would be able to talk to the benefits of standardization. For us, it's a strategic model. So for us, having repeatable designs allows things to be operated by a technician on one site. They can go to the next site. They can operate the same thing. They don't have to read a manual before they do anything. It looks and feels and works the same way as the thing they saw at the last site. So there's a really simple and easy advantage to standardization. But what it allows us to do at a planning level as well is, as we deploy designs and we deploy repeat designs wherever we can, and we make changes to those, we can see what works. We've actually got a reasonable sample to go back to and look at and decide that was worth doing, that actually wasn't worth doing. This happened, but we didn't foresee this other thing. And if it happens once, sometimes you throw the baby out with the bathwater a little bit. You have one thing go wrong somewhere, and you think, oh well, that's not working. Let's not do that again. But standardization allows you to do things on an asset level, on a fleet level, on a state-based level. It allows you to do multiple things and bring back data analytics through what you're designing and deploying to make real, make real data-driven changes to the way that we do our work.
Yeah, brilliant. And then how does design quality fit into all of that?
Yeah, we take our design quality seriously. I mean, as soon as you mentioned ISO 9001, I think shutters pull down over most engineers' faces. But it's, I think there's something in that. There's obviously something in that standard because everybody has to comply with it for accreditation. But for me, I think there are really key and important elements to that I see in the wider engineering community aren't so well appreciated. Obviously, the nature of design and requirements definition and bringing design inputs is kind of obvious. You can't really produce something unless you know what the brief is. And peer review is also, I think, fairly widespread. But the parts of the standard that I think are less obvious to people are the design validation, and I think this is also, again, a differentiating for people in my team compared to what a career designer might otherwise do, who doesn't see very much of what they design once it hits, unless it's something quite big and that engagement is there through the end of the build process in that kind of superintendent capacity. A lot of the times people don't really see the end of what they built, let alone what it looks like in 10 years' time. Whereas for us, we see that we live it each day, and that design validation is a real feature of our quality management system, where engineers will go back and check, did the thing that was built match the thing that I designed? Where could I have improved it? What did I do that wasn't necessary? What did I do that really worked well? And we have a real learning organization culture, and certainly within the team, we're quite big on that. We're sharing lessons on a daily basis, pretty much things that people found out that other people may not be aware of, and circulating that through the technology platforms that we have within the business is I think it's great. It's engineers are sometimes sort of keeping to themselves in their own little world, and I think, but everyone is a font of knowledge, and I tell the team all the time that if I'm learning something every single day, then I'm pretty sure you guys are as well, and we need to share that, and so we got great platforms to be able to do that.
That's great to hear, Pat. And so I guess that sort of design then, the next phase in design becomes build, right? So you've got the design quality, then the build quality. So I guess you kind of touched a little bit on quality in design, but how does that then flow into the build phase?
Yeah, so I've some hard-won experience there has really informed our selection of equipment suppliers and then also installers, so our contractor base. We very much favour a partnership model. I think we engage external parties for the production of certain pieces of equipment and for site installation services. That's, I think, the right model to use. But at the same time, I think it's healthy to have people in a partnership type relationship where people can feel safe around each other, and again that information flow is easy and seamless. And for us, it really starts with suppliers. So these are people who make control panels and switchboards and other boxes that we deploy. And the relationship we have with them is that we produce network standards, and these are things for one example might be a HVAC control panel, for example, at a complicated site that's managing redundant plant, and it's managing free cooling so that we get an economic benefit and also an emissions benefit when the ambient temperature is low enough and the humidity is right, and there's no smoke and all those other things that we watch for. But all of that happens in a control panel that we don't buy that. You can't open a catalog and pick that up. It's not out there. So what we do is we work with in this case, a preferred control panel supply partner, and we agree the design with them, and then they produce those units. And so then once that whole process is up and running, then compliance is covered, standardization is covered, design quality is covered, and the good thing about the designers being able to leverage off those we call them engineered products, is that they don't necessarily need to understand every piece of design detail. If they're deploying a HVAC control system for a large site that's being upgraded, they don't need to understand every single thing that's inside that box, because that design has been squared away. They need to understand what it does, how the inputs and outputs work, but the detail of the inner workings is really held at the network standard level, and it's the senior engineers and myself and the team leaders that do a lot of that legwork so that they can really make their site designs much quicker, because they're already building on that foundation, if you like, of expertise that's gone into those engineered products.
And that obviously contributes to a better quality.
Absolutely, yep. And then we free issue those products into projects for our contractors, and again, those contractors, they're partners with us, so they know what our designs are. There are network standard products that I've spoken about. There are also network standard installation packages, and they tell contractors how to install small air conditioners, how to run low voltage cabling, how to run fuel pipe work. There's any number of them, and once this is the partnership benefit, I suppose, again, is that once you deal with the same people over and over again, different sites, different states, those things just become part of the relationship, and then we're not taking those standards to a new person every time we try and do something, and educating them on how things are needed to be done. It just becomes an exercise of change management, and that's a much better place to be in, and you can then really get stuck into continual improvement, not just internally through your design, through your engineering, but also through your build, through your externals as well.
Fantastic. All right, so we kind of touched a little bit on this a bit earlier, but redundancy, so the stuff that will help you sleep through the night potentially, but can you tell us a little bit about redundancy?
As much as we're available for the calls, but no one ever really likes the calls, so redundancy is one thing that means we don't get called so much. So there's people familiar with Uptime Institute tier levels will be familiar with a certain type of there are 4 basic types of topology that apply, and we use a system that it's depending on the application, and talking sort of broadcast sites here, and the difference being for even high availability broadcast sites is that there's generally a tolerance for a short interruption between mains power and standby power connection. So that really kind of takes it out of the Uptime Institute tiering system because of that. But having said that, we certainly grab a lot, and the accreditation I mentioned earlier gives us a good basis to work on for understanding where to invest. And I see through my career I've seen a lot of a mix of things. It very rarely gets the sweet spot, I have to say. What you see more of it is more overcapitalization, which is people not really understanding the availability target that the whole system was meant for, and then how that translates back into every design decision. What do we make redundant? Where do we put diversity? Where do we build resilience into the infrastructure? And so redundancy for us is about selectively, and again, this is all that hard-won experience feeding back into design. Is which pieces of equipment do we actually need N+1 or N+N? Do we need to have a sort of a fail-safe operation? And we talk about this ties into a couple of other principles. One being integration, which is understanding the part that your system plays in the overall delivery of a product. And the example I like to give to visualize this is, you see data centers where they'll pour millions of dollars into generators and UPSs and bypasses and diverse supplies for everything, and everything fire segregated, so that if anything goes wrong, we're safe. And it's literally tens of millions of dollars, but then people won't appreciate that, well, that facility is actually hot swappable with a mirrored site somewhere else. And so really, if anything happened, it wouldn't matter. And so that's that risk of overcapitalizing and not understanding the integration.
Switchable recovery, which kind of it's almost kind of linked, right? Isn't it? It's all sort of like follows on from each other.
Yeah, very similar. And this is really just that appreciation of how sites are operated and what we can afford to make, what we need to make automated. And automation brings its own benefits, but also its own risks and its own complexity. But then also, what do we need to put in place so that when an operator attends site, there's a way for them to restore services. And there's a big difference between doing that or having them get to site, have nothing that they can do, call somebody, they don't know what to do because there's no easy pathway. And then, that's when, a potential 1 hour problem can become a 1 week problem, which is obviously a huge difference. And so that switchable recovery principle applies to that.
We hear a lot from our customers, from our broadcast customers these days, around overall uptime. And previously we used to be able to do maintenance by switching off services, but it seems like with so much competition now from competing services and platforms, broadcasters don't want their services off. So non-disruptive maintenance. Can you talk a little bit about that and how you incorporate that into your designs?
This draws on a principle of data center principle of concurrent maintainability, and it's really again, it's about being selective, understanding where you can get easy wins, and knowing how things are maintained is actually a feature in being a good designer. And I think that really talks to that principle, which is just giving people where it's an easy option and where it's a cost-effective inclusion is to make that system concurrently maintainable so that it can be safely taken offline, maintained, placed back into service.
We keep going back to the response that your team provides, and the waking up at say 1 o'clock in the morning to provide some support. Remote accessibility, how does that contribute to, I guess, making your life a bit easier and also providing the broadcast services?
Yeah. So it's, unfortunately we can't be everywhere for everybody, and so being able to dial into somewhere, well, that's probably not the right term, connect into something, and a little bit more advanced than that.
Gone back a few years.
Yeah, being able to connect to, showing my age a bit there, connect to something and resolve the issue, at the end of a laptop is obviously the goal. And that really applies to just about anything these days. I think in the last 10 years in particular, we're seeing the types of things that you can connect to and operate remotely as though you were standing in front of them has expanded dramatically. And now even some of the smaller components that live inside a bigger system will have their own Internet of Things connectivity. And I still think we're really at the start of that. And as we look further and further, 5-10 years down the track, I think there'll be a further explosion of IoT type devices that facilitate that distant connection. And that's it's a real plus for us because it allows us to do more from far away, and that again just folds into our support function that we provide for our teams.
Okay, so the last of your 10 commandments / principles, I like to call them commandments. I like the sound of that better than principles, but future ready, and this seems to be an interesting one when we discuss the future of the network with a lot of our customers. There's a lot of talk about being available in various conditions, such as hot climate, cyclones, and all sorts of stuff. And we've seen quite a bit of grid disruption recently as well. So, how do you sort of factor in to your designs some sort of future capacity or being future ready for anything that may present itself?
A part of that we've spoken already, which I guess through the life of the asset, that's part of our future readiness. And I think buildability, maintainability, operability, those things kind of covered in the earlier principles. I guess the external factors are the trickier one. And you mentioned changes that we should be able to anticipate at this point that over the life of our assets that they'll be subject to. There's also a related but also unrelated aspects of regulatory change, and what do we see happening in the safety and the environmental arenas in particular around changes to frameworks, regulatory frameworks, state by state, country by country, in that sort of 5, 10, 15 years plus time frame. And then there's just a side around technology, and where do we see technology being in that length of time. And we don't want to be in a position where, so we're deploying quite a bit of renewable energy generation at the moment, solar PV systems, and 20, 30 years ago, some of the larger sites with sort of switchboards of that vintage, well, it's no surprise that they didn't include a connection for a future future solar generation system. So, but I guess that's without trying to understand everything that's going to happen and crystal ball accurately. I think just building a little bit of flexibility just to manage the unknown will be, that you could potentially see coming through in that time frame. I think it helps to helps to think ahead, and so we're doing that. And I mentioned regulatory change, technology change. We're looking at alternative fuel sources, obviously a bunch of renewables. To borrow off another phrase, so starting with the end in mind, looking at what really brings success for me is retiring an asset after it's more than what it was designated for years of service, because we look after our assets, and then looking back over its life and thinking that actually performed really well, did everything that we needed it to do, and if I had my time again, I'd go back to the beginning and do it exactly the same, not add more, not take things away. That's what success looks like for me and my team.
Well, Pat, we refer to power in buildings as passive assets, but from the discussion we've had today, it sounds like there isn't anything passive about what they do. Pat, thank you. BAI's Patrick Maraun telling us about the very important role he and his team play in keeping broadcast services to air 24/7, 365 days a year. No power equals no transmission equals no favorite shows. For more info on what Pat spoke about today, click on the link provided on the podcast webpage. If you have any questions on today's session, please get in touch with either Pat or myself. Catch you next time for session 2, where we'll be joined by BAI's Grant Shapcott, who will be talking to us about all things structures, antennas, RF components, as we dig deeper into the engineering that makes the broadcast machine tick. Thanks, Pat.
Thanks, everyone. Thanks, Mas.